Okay, so now the last one is linearly varying load. Okay, in the case of linearly varying load, what we have is a triangular load, and that triangular load is there any issues? Huh? Okay. So in the case of linearly varying load, we have, imagine you can easily work out the reactions. Okay, remembering that from the centroid till the end with the highest magnitude, that is 1/3 of the base. Okay, so 1/3 of the base is the distance of the resultant from the point where you have got the largest magnitude of the load. Yeah, so is that okay? So you can easily find out this is 10 kip, this is 20 kip. Okay. Now the issue over here is again what would be, okay, first of all, the variation between the load, that's linear. Okay, that's this one. So the shear would be parabolic and moment would be cubic. Is that right? Yes. So we'll have to draw a parabolic curve to account for shear. Now, how can we, first of all, we would have this one move to 10. Now, how should, and then over here we would have 10, and over here we would have 20. Now, guys, please, can I have your attention over here? How should I join? It has to go somewhere. It has to come down to 0 over here somewhere. Yes. So, if this is coming to 0, how would I join it by a curve? Parabolic, but parabolic we can have.
Sir, its slope is increasing, so we will put.
Yes, we can have either this or this.
Sir,
parabolic.
Sir,
Why like this?
Slope is increasing.
Because the load is 0 over here. Yes, so we would have slope approximately 0, and then this will increase like this. Now from here it would have yes, so it will have a same pattern. So that means that we would have it something like this, isn't it? And similarly for this one, what would we have? The moment, what moment we would have? We would, the point where we have got maximum shear, that would have slope equal to, what would be the slope? This has got finite shear. How can it be zero? It can't be zero. So you will always have slope, which is something like this, isn't it? It's not zero. So you can't have this thing zero. You will always have some slope, and it would be something like this, and that would be a cubic curve.
Yes.
Cube. Now the problem is how to find out this point where we have got zero shear. And how would we do that? How can we do that? Unfortunately, in the case of linearly varying load, we can't use graphical procedures. Okay, so we have to resort to the first principle, which is we have to find out what shear is at a particular point. Okay, and equate that to zero. So in other words, this is my y. I assume at a distance x. What is my y at a distance x? So, what is this magnitude? Huh? So, I can write
y/x is equal to 2/13.
2/13 is equal to y over x. Y is equal to x over 15. Now, we can find out the area.
Yes, sir.
What is the area? Half x into x over 15, which is equal to x square over 30. Now, this area must be equal to
Salim said, is the class about to end or is there some time?
what time is your class?
No, sir, we don't have a class. We have
So then why are you coming inside?
a small announcement to make.
No, sorry, my class is about to end, so you can then make it after some time.
Sir, I want to request to everybody please stay for just 5 minutes. It's a small announcement.
Okay. Okay, so therefore area is equal to, so we have got area available over here. Now,
Yes, sir.
now what should we do? How can we find out this point? Come on, hurry up. How can we find out this point?
This area must be equal to 10.
Summation of Fy must be equal to 0. I need that point. So, summation of Fy must be equal to 0, isn't it?
Yes, sir.
I've got that equation. So, I will have 10k. 10k. minus
Sir, this area was given you.
s x square by 30. 10 kip minus x square by 30 must be equal to 0. And from here I can find out my x. So I have to, so that's why I call it that we have to go through the first principle to find it out. Okay? So that is, so I'll be giving, sorry?
Could you summarize it again?
Yes, what I'm saying is, the point is, how can we find out the point where we have zero shear? Why do we need zero shear point? Because at this point, we have maximum moment. Yes, we have got maximum moment. Now, how do we work it out? First of all, a generic area of this triangle. Okay, you find out the generic area. So at a distance x, we find out y, and we find out the area of this generic triangle. Now this generic triangle, so the point where we will get zero shear, at that point the applied load, okay, at that point all your summation of forces must be equal to 0. So 10 kip in this direction minus the load which is facing down. Those two must be equal to 0. And that's what I'm saying, that if these two are equal to 0, that will give us that point when we have zero shear. Do you understand my point? So this 10 kip, I need that area which will give me the same 10 kip in the opposite direction, so that they both cancel out and I get zero shear. That's what I need, isn't it? So that's what I have done here. Okay? That's it. Okay, so that's the end of this session. In the next class, we will try to start from influence lines, and we'll discuss that one. This is your bending moment shear course for frames is over. Okay, so can you